To study permutations and combinations, the student should be able to understand factorial notations and factorials. What's its factorial? Factorial is the product of the first n natural numbers. Let's study about the factorial. We often come across products of the form 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4, and so on. Instead of writing all the factor of such a product in full, it is convenient to use expansion notation factorial. This is the factorial notation, n factorial and factorial n. We can expand n factorials equal 1 times, 2 times, 3 times, and so on, n minus 3 times, n minus 2 times, n minus 1 times n. We can define n factorials is the product of the first n natural numbers. This is n factorial. Let's see, n factorial, we can expand like that: n times, n minus 1 times, n minus 2 times, n minus 3 times, and so on, 3 times, 2 times 1. Okay, let's see. 5 factorial. 5 factorial equal 5 times, 4 times, 3 times, 2 times 1. The result is 120. Then 4 factorial. 4 times, 3 times, 2 times 1. The result is 24. Let's think again. 5 factorial equal 5 times 4 here. 4 times, 3 times, 2 times 1 is equivalent to 4 factorials. So we can substitute 5 factorial equal 5 times 4 factorials. 5 times 24, the result is also 120. The next one, 3 factorial equal 3 times 2 times 1 equal 6. Okay, then again about 5 factorials. 5 factorial equal 5 times 4 times 3 factorials. Let's check. 5 times 4 equal 20 and 6 factorial equal 6. So the result is also 120. So we can conclude, if m and n contain in n natural number m greater than n, then m factorial can be expressed in terms of n factorial. Let's see example. 8 factorial equal 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We can written 8 times 7 times 6 times 5 factorial or 8 times 7 factorial. Now think about 1 factorial, m factorial and n factorial. We have known n factorial equal n times n minus 1 times n minus 2 times and so on 3 times 2 times 1. Six factorial equal 6 times 5 times 4 times 3 times 2 times 1. Similarly, 3 factorial equal 3 times 2 times 1. 2 factorial equal 2 times 1. 1 factorial equal 1. We can see clearly 1 factorial equal 1. Moreover, if m and n belong to n natural number and m greater than n, then m factorial can be expressed in terms of n factorials. 8 factorial equal 8 times 7 times 6 factorial. If m factorial equal n factorial, then m equal to n. It is clear that vice versa, if m equal n, then m factorial equal n factorial. Let's think about 0 factorial. We have known n factorial equal n times n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1. We can deduce n factorial equal n times n minus 1 factorial. Put n equal 1. We have the equation. The left hand side is n factorial and the right hand side is n times n minus 1 factorial. 1. We put n equal to 1. The equation becomes 1 factorial equal 1 times 1 minus 1 factorials. So 1 factorial equal 1 times 0 factorial. Here we have known 1 factorial equal 1. So the equation began 1 factorial equal 1 times 1. So here 0 factorial must equal 1. We can conclude that 0 factorial equal 1.